Hi, today we're going to stay with the same example from yesterday. So we had a local hospital measuring blood pressures of patients, and it found out that it was normally distributed with a mean of 110 and a standard deviation of 10 millimeters of hemoglobin. Just so you know, there is a notation. It looks something like this. Some places leave out this little tilde symbol, but it's N and then a set of parentheses, the mean, comma, standard deviation. So if you ever see that, that's shorthand for normal model. You'll see later with a binomial model, they'll use a B and a G for geometric later in the year as well. So just shorthand for something that you've already talked about. So we said today we were going to work backwards and figure out area under the curve. And figure out which x values along the x-axis here go along with those specific percentiles. So a typical type question would be like, as long as we know that it's normally distributed, what blood pressure level represents the 35th percentile of all blood pressures? Okay, so you could kind of use your empirical rule to figure out approximately where we are. We know that this was about 2.5% of the data, and then we know we had another like 13.5% here. So we know we're probably somewhere in this region here for just figuring things out quickly in our head. But we can use our graphing calculator to find a more precise answer. Okay, so we're going to go into the same menu that we worked with yesterday. And I realized yesterday's video I did not show you the VARS button, and a few people had trouble finding that. So your VARS button is right here. It's below the arrow. So you hit second and then VARS. And that gets you into the distribution menu. Today's function, we're working backwards. So we're actually going to use something called InvNorm. So it's option 3 here. Okay, so reminder, yesterday we were using option 2 for the cumulative density function, and today we're working backwards with InvNorm. Okay, so you have a similar type of menu, and if you have an older calculator, you're just going to type these numbers in order with commas between them. The newer calculators, the TI-84 pluses, the one that you're seeing in front of you, you're just going to fill out this menu and hit paste. Okay, so I already messed with this a little earlier. You can see, so we have the 35th percentile, so the area under the curve is 0.35 that we're looking to identify. And then you have the mean for this problem of 110 and a standard deviation of 10. So you just go down to paste it into the InvNorm function. If you scroll to the left a little bit, you can see that is the calculator function that they're using, and then just hit enter. And that number that they give you is the x value along the x-axis that corresponds with the 35th percentile. Okay, so 106. So a blood pressure, let's see if I can spell pressure correctly today, of 106.1 is probably fine. Millimeters of hemoglobin represents the 35th percentile for this distribution. Okay, so that's our first one. There's many other variations of questions, but I'll just go through one more with you. One sec. What is the blood pressure level that represents the top 5% of all observations? Okay, so think about that. That is way up here in the higher tail. And if it's the top 5%, that means that 95% of the data is below. So we are looking for, with this top 5%, the 95th percentile. Okay, so that's just another way that they twist the problems around to give you a little bit of trouble. Okay, so we're going to use the same function in our calculator. We'll use second VARS to get us to the distribution menu, and then option 3 is the one that we want. And then the only difference here is that this time we are looking for the 95th percentile and not the 35th percentile. So I'll just change that, hit paste, hit enter one more time, and you can see the x value that corresponds with that. So 126.45. Okay, and hopefully that makes sense. We know that the top 2.5% is right here, so the top 5% is just going to be a little bit lower than that. Okay, so you would just answer a blood pressure level, similar setup to the previous answer. 126.4 represents the 95th percent, or you want to stay with the problem, so represents the top 5%. Okay, and I guess I should say here too, a blood pressure of 100 or higher represents the top 5% of pressure levels. Okay, and I'm sure there's several, so you want to put that or higher there to represent the entire top 5%. So there's a couple other variations. They could ask you about the lowest 5% and some other things. They could ask you about areas in between, but these are the typical ones that they'll ask. Okay, so you'll have a few more problem sets like this here today, and that'll probably wrap up all we need to know for now about the normal distribution. Later on in the year, when we get into something called sampling distributions, we'll come back to this model, but it'll be good enough to go through this just for now. Okay, thanks again for watching.